Welcome everyone to this explainer. Today we are tackling what is honestly one of the most critical, yet surprisingly tricky areas of the entire Cambridge Mathematics 9709 syllabus. We're talking about series. Specifically, we're going to be looking at geometric progressions, convergence, and the sum to infinity. Now, we haven't just guessed what you need to know. We've actually pulled direct data straight from the Cambridge syllabus and the official examiner reports to build you the exact step-by-step framework you need to completely master this topic. Let's get right into it. So right off the bat, we need to address a pretty stark reality, and this is something echoed time and time again by principal examiners. They state, plainly, most students lose easy marks on series. I know, it sounds a bit harsh, right? But it's just the reality of the exam room. You see, so many students walk into that exam hall feeling super confident about geometric progressions. They figure, I just need to memorize the formula, plug some numbers in, and boom, I'm done. But then, the results come back, and those guaranteed easy marks, they've just completely slipped through their fingers. It's incredibly frustrating. Okay, let's dive into this. Why do students find this distinction between key terminology so incredibly hard? Why does a topic that, on the surface, seems so computationally straightforward turn into such a massive pitfall for so many smart people? Well, that is exactly what we are going to unpack today. I want you to consider this explainer your ultimate insider playbook. We are going to decode exactly what is happening in that exam room, show you exactly how to avoid these common traps, and most importantly, how to lock in absolutely every single mark available to you. Section 1. Core Principles. What examiners actually want. To really understand the problem here, we have to look closely at the academic benchmarks. Look, examiners do not just care about the final number you write down at the bottom of the page. What they actually want to see is a connected, conceptual understanding. Think of it like this. Average candidates tend to rely on what we call superficial breadth. They basically just try to memorize a massive array of formulas and hope for the best. Top performers, on the other hand, secure those high marks through analytical depth. They don't just mindlessly compute, they actively analyze. For instance, they'll use a clear, evidence-based approach to prove exactly why the absolute value of the common ratio, R, is strictly less than 1 before they even attempt to calculate the sum to infinity. It's about showing the logic behind the math. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving on to Section 2. The technical methodology, a standardized sequence. So how exactly do we achieve that analytical depth we just talked about? Well, we do it by treating mathematics as a highly systematic process. I'm going to walk you through a strict 5-step standardized sequence right now. Step 1, identify key elements. This means extracting the exact relevant information you're given, like spotting your first term or identifying your common ratio right away. Step 2, apply relevant principles. Here, you're selecting the correct analytical framework. You're asking, is the series geometric? Does it actually converge? Step 3, execute analysis with clear working. This is absolutely crucial. You have to show literally every single step of your calculation. Step 4, verify results. Take a second to check for reasonableness. Does your answer actually make sense? And finally, Step 5, present in appropriate format. Following this exact sequence guarantees that your reasoning is logically structured from the very first line to the final answer. Now, this 5-step sequence perfectly aligns with the ultimate problem-solving framework outlined directly in the Cambridge syllabus, which is deconstruct, solve, evaluate. Securing those top-tier, higher-order marks demands so much more than just basic calculation. It literally demands that you evaluate your assumptions and consider alternative interpretations. For example, you need to be able to evaluate the limitations or the assumptions you're making when you confidently declare that a sequence converges. You deconstruct the big problem into small logical steps. You solve it systematically, and then, and this is the key part, you critically evaluate your conclusion to ensure it absolutely holds up against the fundamental mathematical principles of the series. Section 3. The ultimate safety net, method marks. When you start using a standardized framework like the one we just covered, you start actively generating what we call method marks. I need you to listen very closely to this official principal examiner alert. They say, even if your final answer is wrong, method marks can save you. Guys, the examiners are literally shouting from the rooftops, warning students that they are throwing away vital, easy marks simply by not showing they're working. Think about it. If you just scribble down a final number and it happens to be incorrect because of, say, a clumsy calculator error, you get 0, nothing. But if you deconstruct the question, show your systematic processing, and make all your logical steps visible on the page, Examiners can and will award you method marks for the process itself. It's a total game changer. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at aceexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's keep going. The absolutely crucial point here is knowing exactly how to physically claim those method marks on your paper. It is not just about randomly scattering numbers all over the page. The presentation of your information has to follow strict mathematical conventions. Clear annotation, proper headings, appropriate formats, and correct mathematical terminology. These are the things that actually secure these method marks. When you clearly state the formula you're using, when you explicitly define your variables, and when you execute your analysis with crystal clear notation, you are actively banking points before your calculator even spits out the final answer. Section 4. The Principal Examiner Warnings. So if clear notation and structured reasoning are the secret to gaining marks, how exactly are students losing them? Well, we combed through the Cambridge Principal Examiner reports to pinpoint the exact traps that catch students completely off guard year after year. Let's look at the top 3. First, answers are often just way too vague. When you're dealing with convergence, examiners want specific mathematical details and evidence-based reasoning. They do not want generic, wishy-washy statements. Second, students just forget to check their format and presentation. Like we just talked about, ignoring those strict conventions will cost you dearly. And third, answers are often not specific to the context given. Higher-order assessment objectives demand that your final answer actually makes sense within the specific parameters of whatever unfamiliar context the question throws at you. To make sure you never ever fall into these examiner traps, I want to give you a really quick memory hack. Whenever you're in the exam, just remember DFC. Details, format, context. Seriously, write it at the top of your page if you have to. Whenever you finish a question on geometric progressions or the sum to infinity, run it through the DFC check. Ask yourself, have you provided specific analytical details? Is your format highly logical and clearly annotated? And does your final answer actually fit the specific context of the problem they gave you? If you can confidently check off D, F, and C, you have completely fortified your answer against the most common examiner critiques. So look at what we've done today. We've deconstructed the examiner reports, we've laid out the systematic 5-step methodology, and we've given you the DFC memory hack to totally safeguard your answers. The ball is completely in your court now. My final provocative question to you is this. Will you apply the deconstruct, solve, evaluate framework to your very next practice paper to claim absolutely every single method mark? Don't just sit there and absorb this information. Put this insider playbook to work today and watch how it completely transforms your approach to Cambridge mathematics. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at aceexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.